right, section 3 in chapter 4. This is unit circle stuff. As far as the unit circle, and I've explained this in class or tried to, the way I'll handle this on the test is you will get a blank unit circle, just like the unit circle quizzes we had, and you will fill that in as part of the test. So that is the unit circle that you will get on the test. I'm not going to give you a completed unit circle. I think that's something that you need to be able to do on your own. So it is important that on this blank unit circle, when you fill it out when you start the test, that you get it all correct. Because if you mess up your unit circle with filling it in when you take the test, then it's going to mess up a lot of your answers later on. So be very, very sure of your unit circle skills. And that said, these are the kinds of questions you are going to see on the test. Notice these do have a star by them, which means you will not be allowed to use a calculator with any sine, cosine, or tangent functions on it. That includes every scientific calculator and your graphing calculators. So you need to be able to do this without a calculator. I went ahead and put a unit circle right here just so I could look at it, but you will have to complete your own unit circle and make sure you have it right. Some of the big mistakes people will make is they'll accidentally get the signs backwards, or like on number 19, let's see, it says find the sine of 150. So most people don't have too much trouble finding the angle 150 degrees. That is, let's see, I may use a highlighter. That is happening right here. There's 150, so we're looking at all of this. A lot of people do have a hard time interpreting what the sine of 150 means. On the unit circle, the sine is the y-coordinate. So when I'm answering number 19, sine of 150 degrees is the y-coordinate, which is 1/2. And that's really all there is to these. You just have to make sure you have your unit circle done correctly. Okay, so let's see. Let's look at number 20. It is the tangent of 7 pi over 6. So let's find 7 pi over 6. 7 pi over 6. That's right here, 210 degrees. So we're looking right here for 7 pi over 6. And tangent, you need to remember, is sine over cosine, which on your unit circle is y over x. So sine over cosine would be negative 1/2 divided by my cosine, which is negative root 3 over 2. And I do want you to get rid of fractions in fractions. So let's see, that would be the same as negative 1/2. If you divide by a fraction, you multiply by the reciprocal, and then we start canceling. 2 cancels 2. And the negatives cancel each other also, and we are left with 1 over the square root of 3, which I am perfectly okay with 1 over square root of 3. If you want to rationalize it, that would be root 3 over 3. I would accept either one of them. Let's see, number 21, the secant of 7 pi over 4. Okay, well, let's find 7 pi over 4. Let me erase this. We're through with this one. 7 pi over 4, that's right here at 315 degrees. And so we have to remember what secant means. And secant is the reciprocal of cosine. So it's 1 over cosine. So secant is 7 pi over 4. Cosine is the x-coordinate, so we're looking at root 2 over 2. And secant is the reciprocal of that. You simply flip it. So root 2 over 2 flipped turns into 2 over the square root of 2. And you know, honestly, and some math teachers or Math League of America, if they're spying on me, they'll be angry at this. I'm okay with 2 over the square root of 2. However, this one does rationalize quite sexy-like. If you multiply by root 2 over root 2, you get 2 times the square root of 2 over square root of 2 times square root of 2 is 2, and then those 2's will cancel, leaving you with only the square root of 2. So that is the nice cleaned up version. If you want to leave it as 2 over square root of 2, I'm really okay with that also. Okay, yep. All right, let's see, moving on. Number 22, the cotangent of 3. Okay, I want to get rid of that box. There we go. Cotangent of 330. Let's see, well, cotangent, let's find 330. 330 degrees is right here. Okay, so if I want to do the cotangent, okay, cotangent, you need to know what that is. It is the reciprocal of tangent, so we could do that, but tangent is not on our unit circle. We only have the x's and y's, which are your cosines and sines. So I'm going to think of cotangent as the cosine of 330 over the sine of 330. And you do need to know those properties. Cotangent is cosine over sine. Our cosine is root 3 over 2. It's your x-coordinate. Your sine is negative 1/2. And when you divide fractions, you multiply by the reciprocal of the denominator. So I'll multiply by negative 2 over 1. And usually there's going to be some canceling. In this case, the 2's cancel. The negative does not cancel, so we are left with negative square root of 3. Yeah. Okay, number 23, the cosine of 11 pi over 3. See, I've got a little bit mean here because you're looking at the unit circle. There is no 11 pi over 3, which means we've got to do something. And 11 over 3, the largest our unit circle gets, if you look at our radians here, is 2 pi. And 11 over 3 is more than 2. So what we have to do is fix this. I'm going to take my 11 pi over 3, and I'm going to subtract the whole circle. This is going back to that coterminal thing. We're going to subtract the whole circle. Let's see, 2 over 1, the common denominator for 3, that'd be 6 over 3. And then let's subtract that and see what we get. 11 pi over 3 minus 6 over 3. 11 minus 6 is 5. And the denominator stays the same. 5 pi over 3 is nice. That is on my unit circle. 5 pi over 3 is right here. So when I'm answering this problem, the cotangent of 11, or cosine of 11 pi over 3 is actually the same as the cosine of 5 pi over 3. And 5 pi over 3 is on the unit circle. Cosine means find the x-coordinate. So your answer is simply 1/2. Good. Okay, number 24, same type situation. Same type situation for number 24. I ask you for the cosecant of negative 120. Now there's two ways you could do this. A negative 120, the way I like to do it is I find positive 120, which is right here, and the negative angle for that is straight down. So if I go from this angle straight down, negative 120 is actually the same angle as 240 degrees because the negative angle is straight above or below the positive one. Now that's kind of a weird touchy-feely way. The more mathy way of finding the right angle is you could take negative 120 and you could find a coterminal angle. So negative 120, that's negative. I want to bring that back into positive angles. We are in degrees, so I'm going to add 360 degrees. You add the whole circle, and 360 minus 120 is 240 degrees. So we are now going to find the cosecant of 240 degrees. 240 degrees is down here, and this is what we said just a second ago. It's right below the 120. And cosecant of 240, cosecant is the reciprocal of sine. Cosecant is the reciprocal of sine. So I'm going to find the sine of 240, and sine is the y-coordinate, and we will simply flip it. So negative root 3 over 2. If you flip that, you get negative 2 over the square root of 3, which I'm okay with that. If you want to rationalize that, that's going to be negative 2 root 3 over 3. I would accept either one of those two. So there we are using the unit circle. And remember, you will have to fill in your own unit circle. Make sure you do it correctly, because if you botch your unit circle, you will botch every one of these problems. So make sure you know your unit circle. You have to get it right. All right, I think, how many more problems are there in this section? Yeah, just 2 more. Okay, these problems, number 25 and 26, are very, very, very similar to some problems earlier in the review. Let me see if I can find them. They were in that first section. Yeah, right here. These problems right here, number 3, where I gave you sine as 2/3, and I asked you to find the other 5 trig functions. We did that by drawing a triangle. We're going to do the exact same thing for these problems in section right here. I forgot what section number we are. So we're going to draw a triangle. The problem, or the difference here, is I'm telling you specifically where to draw the triangle. So we need to draw our triangle going into the second quadrant. So I've assigned some graphing restriction to this. So if I'm going to be in the second quadrant, I need to draw the second quadrant. Now, I'm really smart. I know where the second quadrant is. It's right there. And I'm going to draw my triangle into the second quadrant. And the way you do that is let's see, I'm going to change colors here. Let's go red. You start at the origin, you go into the quadrant, and then you go back to the x-axis. It's imperative that you draw your triangle correctly. Do not draw your triangle into the quadrant and then back to the y. You don't want to do that. I see people get the triangle drawn wrong. You start at the origin, go into the quadrant, then back to the x-axis. Your angle theta, your angle theta is right here. And if you're given sine is, remember SOHCAHTOA, SOHCAHTOA. Sine is opposite, so 1 is my opposite, and hypotenuse, and 5 is the hypotenuse. So from theta, I know my opposite side is 1, my hypotenuse is 5, and we do need to find the adjacent side. And so that's going to be Pythagorean theorem. So a squared plus 1 squared is equal to 5 squared. A squared, 25 minus 1 is 24. A is the square root of 24. 24 is 4 times 6. And the reason I chose 4 and 6 is because the square root of 4 is sexy. That's 2. So A is 2 root 6. But you have to be careful. This is why the quadrant is important. Because if I start at the origin and I travel left and then I travel up, if I travel left, that is a negative measure. I'm going left on my x-axis. So while the length is 2 root 6, my A is actually negative 2 root 6 because I traveled left. And if I traveled left and down, then my other side would be negative as well. In this case, I went left and up. Going up is a positive y change. So we'll keep a positive 1 for the opposite side. But anyway, now we do have all 3 sides, and we can go from that to answer the 6 trig functions. Sine is 1/5. That was given to you. Cosine is adjacent over hypotenuse, which will be negative 2 root 6 over 5. Tangent is opposite over adjacent, which is 1 over negative 2 root 6, and I'm not going to rationalize that. Cotangent, you simply flip tangent. Once you get those first 3, the last 3 are easy. Negative 2 root 6 over 1. Cosine and secant are reciprocals, so this will be 5 over negative 2 root 6. And sine and cosecant are reciprocals, so 1 over 5 flips to 5 over 1. So there are the 6 trig functions. So we'll see. So there we go. You have to decide what quadrant you're drawing in, and that affects whether your dimensions are positive or negative. Keep in mind your hypotenuse is always a positive measure. You never have a negative length for your hypotenuse. All right, let's see. Tangent is 2/3, and cosine is negative. Now this one's a little bit trickier because I didn't just outright tell you in which quadrant to draw your triangle. So if tangent is 2/3 and cosine is negative, let's think about our unit circle here for a second. Let's think about our unit circle. Tangent is positive 2/3. Tangent is positive 2/3. Well, tangent is going to be positive. Remember, tangent is sine over cosine. So tangent is going to be a positive measure whenever sine and cosine are either both positive or both negative. And if you think about the signs of your x and y coordinates in your first quadrant, x and y are both positive. In the second quadrant, that's a negative x and a positive y. Down here is a negative x and a negative y. And if you're in the fourth quadrant, that's right, that's a positive x, and down, which is a negative y. Let's see, if tangent is positive, that only happens when you divide 2 positives or if you divide 2 negatives. So I know that I'm going to be looking somewhere in either the first quadrant, because if you divide 2 positives, you get a positive tangent. And if I do sine over cosine in the third quadrant, you will get a positive answer. So I've now eliminated these 2 quadrants. So I know I'm not looking here. Then I need my cosine to be negative. Well, cosine is your x-coordinate on the unit circle, so that's kind of how I think about this. I need my x's to be negative. And x is negative, let's see, x is negative right here. So there's where my x-coordinate is negative, which rules out my first quadrant. So by looking at the sine, the tangent is positive and the cosine is negative, that only happens in the third quadrant. So now I'm going to draw my triangle into the third quadrant. And remember, when you draw your triangle, you go into the quadrant, from the origin into the quadrant, and then back to the x-axis. Okay, tangent is think about SOHCAHTOA, tangent is opposite over adjacent. So if my theta is right here, you always draw your angle back to the x-axis. Opposite is 2, and adjacent is 3. But we have to be careful because if I go into the third quadrant, I'm traveling left and then I'm traveling down. Both of those are negative movements. So it's actually -2 and -3. And then to get my hypotenuse, I'll do the Pythagorean theorem. So -3 squared plus -2 squared is my hypotenuse squared. -3 squared is 9, -2 squared is 4. 9 plus 4 is 13, and I will take the square root of that, and your hypotenuse is the square root of 13. Now remember, your hypotenuse is always a positive measure. Do not call that -13. You always have a positive hypotenuse. And once you get your triangle drawn, the rest of this should be easy. Finding where and how to draw the triangle is the tough part. The rest of it is straight up SOHCAHTOA. Sine is opposite over hypotenuse, which will be -2 over root 13. Tangent is adjacent, -3 over root 13 over the hypotenuse. Tangent was given to you, that's 2/3. And then we start flipping. Flip tangents get cotangent, so that'd be 3/2. Flip cosine to get secant, so that'll be root 13 over -3. And flip sine to get cosecant, which is root 13 over -2. And I think that does it for this section. It does. So there's your unit circle type questions, even though the last two problems were not on the unit circle. And you will not, I should have put this on, I meant to star this problem. Did I star number 25? No, I didn't. All right, for these problems, I'm actually not going to allow you to use a graphing calculator. Because one, some of y'all are going to try to cheat the system and find the measure of theta by doing inverse tangent. And you have to be careful because it may give you the wrong angle. It's just kind of a bizarre thing. I'm not going to let you use a calculator on number 25 or 26. That's actually going to be for your benefit because if you trust your calculator too much, it may give you the wrong answer. Isn't that scary?